Hello, in this video we're going to review how to deal with linear equations. And we're going to solve a linear equation, we're going to look at graphing of linear equations, and then we're going to use them in a word problem. So let's go ahead and get started with that review. I'm using the notes here that I've put on the website, on the Blackboard site, and you can go ahead and print those out if you want to, or just kind of keep notes as you go. It just kind of gives me a structure for note-taking if you'd like to use that. We're going to start off with the idea of solving linear equations. And I've got an example. The example I want to use is 0.4x minus 0.2 equals 0.6x plus 3. And if you recall back to your previous algebra days, the first thing that you always want to do is get all of the same terms on one side. And on this one, since we have some decimals involved, we could actually clear the decimals if we wanted to. If we had fractions, we could clear those. It's an optional step, but I'm going to go ahead and do that just so we can remember how to do that. And in order to clear the decimals, what I'm going to do is I'm going to multiply both sides through by 10. I'm going to multiply everything by 10, so that's just going to distribute everywhere. So 10 times 0.4x will give me 4x. 10 times a minus 0.2 will give me minus 2. 10 times a 0.6x will give me 6x. And 10 times 3 will give me 30. Now I'm going to try and get all the x's on one side, and it doesn't matter which side you go to. You can go to either one side or the other. I am going to go to the left side, but if you like to stay away from negatives, you can do that as well. So I'm going to subtract 6x from both sides, so the 6x's will cancel out over here, and I'm going to get negative 2x minus 2 equals 30. I'm going to add 2 to both sides, so that'll cancel out the 2, and I'll have negative 2x equals 32. Divide by negative 2 to undo this multiplication. And my answer is negative 16. Whoops. There we go, negative 16. Okay, so that's how to solve a basic linear equation. I'm also going to look at how to solve an equation that looks like this. A equals P times, and this is an equation you'll see later on in the course. And what I want to do, notice this one has a lot of variables. The other one only had one variable, but that's okay. If I want to say that I want to solve that for r, what that means is I want to get the r all by itself on one side and everything else on the other. Just like on the previous example, I got x all by itself on one side and all the numbers on the other. So there's two ways you can go about doing that, and I'm going to show you both ways. So here's the first way. What I'm going to do is I'm going to start by dividing. I want to get rid of this p. So I'm going to divide both sides. Since this is a multiplication, I'm going to undo that multiplication with a division and divide by p. That will give me a over p equals 1 plus rt. Now I'm going to subtract 1 from both sides. So that'll give me a over p minus 1 equals rt. And then I'm going to divide both sides by t. Or, the easier way to do that, since I've already got a division over here, would be to multiply both sides by 1 over t. Hopefully this is coming back pretty quickly to you. And that leaves me with an r over here. And over here on this side, I'm going to distribute that 1 over t. So that would give me a over tp minus 1 over t. And that's equal to r. So there's my solution. Okay. Or, the second way we could have done this is we could have started by distributing this p. So that would give us a equals p times 1 is p, plus p times rt is prt. Then I can subtract p from both sides. So I get a minus p equals prt. And since I have multiplication here, I can divide both sides by the PT. And so I get R equals A minus P over PT. Both of those solutions are completely fine. When you are doing problems like this in my math lab, it may give you, it may say that your solution is wrong. And if you have done a problem a little differently than maybe they showed, you know, you've done the second way instead of the first way, or the first way instead of the second way, and you think your answer might be correct, feel free to send a question to the instructor, and I'll take a look at it, and if it's right, I'll count it right. Okay. But if you actually get common denominators over on this side, which would be multiplying by P in both numerator and denominator, then you'd have TP as your denominator, and you get A minus P as your numerator. Notice they are the same, they just look different. All right, so that's solving linear equations. The next thing I want to look at is the idea of slope. And if you remember slope is the rise over the run of a particular line. How much it goes up versus how much it goes over. All right? And the way to find that is just by looking at the difference in the two y variables over the difference in the two x variables. So for instance, if I gave you 2 points, I gave you the point -2, 5 and the point 3, -4, and I said find the slope, you would take the difference between the two y's, and it doesn't matter which one you say is y1 or which one is y2, as long as you're consistent. If this is x2, then this has to be y2. Okay? So I'm just going to subtract, I'm going to take this minus that. So -4 minus 5 over 3 minus a -2. It's going to give me -9 over 3 minus a -2 is the same as 3 plus 2, which is 5. So you get -9 over 5. Now you could write that as -9 over 5, or you could also write that as the -9/5. Or if you had done this as x2, y2, then you could have come up with 9 over -5. All three of those are identical, again, just as above, and any one of them is going to work fine for the answer. Okay? All right, so that's finding slopes. But now let's look at the idea of graphing. And let's say we want to graph the following equation. Let's say we want to graph 5x minus 4y equals -20. And we want to use the idea of intercepts. All righty? What we're going to do for intercepts is we're going to say, let's take our x's and our y's, because we remember that when we're dealing with intercepts on the x and the y axis, that what we have done is we have made either, so here's our graph, here's our x-axis, and here's our y-axis. Everywhere on the x-axis, your y value is 0. Everywhere on the y-axis, your x value is 0. So what we're going to do is we're going to go over here and we're going to take 0 and we're going to put it in for x and for y, and that's going to tell us what our two intercepts are. So if we put in a 0 for x, that means this term is gone, and we get -4y equals -20. If I divide both sides by -4, I get y equals +5. And that's my y-intercept. If I let my y be 0, and that takes this term out of it, I get 5x equals -20. Divide both sides by 5, I get -4. That is my x-intercept. So if I go over to my graph over here, I have a y-intercept of 5. It's right here. And I have a x-intercept of -4 right here. And I've got 2 points that uniquely determines a line, so I can just connect the dots. And there is my graph of the line 5x minus 4y equals -20. All right, the other way that we could do this is by using something called the slope-intercept form. And the slope-intercept form looks like this. y equals mx plus b, where m is your slope and b is your y-intercept, where it hits the y-axis. So if you have something like y equals negative 2x plus 5, and you want to graph that, well, you already know all the information that you need. This will give you a point on the graph. It will give you the point y equals 5. 1, 2, 3, 4, 5. Okay, but you need 2 points in order to graph a line. And so what you do is you say, I've got this point, and I've got a slope of negative 2. That tells me how things change from point to point. So remember we said that it was rise over run. So I want this as a fraction. So I could do that as either negative 2 over 1 or 2 over negative 1. And I could say that I'm either rising negative 2, which means I'm falling 2, and running in the positive x direction by 1, so down 2 and over 1. Or I'm rising 2, 1, 2, and I'm running negative 1, which is 1 in the negative direction. And notice all those points are on the same line. So I started with my y-intercept, and then I use my slope to find another point. And you can go either direction, it doesn't matter. So that's solving linear equations and graphing linear equations. The last thing that I want to look at is the idea of mathematical models, or using these for a word problem. Let me zoom out just a hair. All right, and I just took an example problem out of the book. Okay, took an even number problem out of the problem set. And it says that a health club charges a yearly membership fee of $95, and members must pay $2.50 per hour to use the facilities. Write a linear model to represent the situation and identify your variables. So the first thing you want to figure out is, what are your variables? What is changing here? Well, the two things that are changing are going to be how many hours you're using the facility and how much you're paying. Okay, those are two things that are changing. And so what we can do is we can use any letters we want. Let's use H. But instead of just saying hours, we're going to say something specific about hours. And we're going to say that H is the number of hours. Alrighty. Then we're going to say that C is our cost, and we're going to say that it's our total cost, because we have two costs here. We have our membership cost of $95, and we have our cost after we have paid for the hourly use. So those are our variables, and you always want to start by identifying your variables. Once you've done that, then you can figure out how you're going to come up with that total cost. So total cost is found by, well, you start with your membership fee of $95, and you're adding to that $250 for every hour. So $250 for 1 hour, $250 times 2 for 2 hours, $250 times 3 for 3 hours. So we take $250 times the number of hours. Notice this looks like y equals mx plus b. I just have switched where the mx and the b are. So this is your slope, and this is your y-intercept. And often when you're dealing with word problems like this, the y-intercept is called the initial value. Alrighty? The initial value. So let's go to part B. It says, use your linear model to find how many hours you used the club if your bill was $515. So we have our equation here. What we know is we know one of the variables. We know our total cost is $515, so we're going to replace C with $515. And now we're going to solve that for a number of hours. So I'm going to subtract 95. That's going to give me 420 equals 2.5 times h divided by 2.5. Grab my calculator here, since I don't trust myself to do it in my head. 420 divided by 2.5 comes out to be h equals 168. So that tells me that I used the club for 168 hours. Okay? Next question says, use your linear model to find out how much it would cost if you use the club 4 hours per week. Alrighty? So, if our cost is found by starting with our membership fee, and that's for a year, plus 2.5 times the number of hours. Now our hours are 4 hours per week, and there are 52 weeks in the year, so I'm going to multiply the 4 times 52. So this will give me the total number of hours. So 4 times 52 is going to give us 208. So during the year we're going to use it for 208 hours. So 208 times 250 is 520 plus 95, gives us a total cost of $615. So $615 for the year. Okay? And that is the section on linear equations.